Sometimes when you plug your Ethernet cable to a wrong part of your switch, it should have caused trouble because it may introduce some loops in your network, but in fact, nothing happened. Your network still works. The reason is your network device have the STP, the spanning tree protocol implemented. But in fact, sometimes you do want to have some redundant link in your network. That's a very important feature of enterprise network as well. Even in your home network, you may also want to achieve the redundancy. STP plays a very important role. So in this video, let's talk about how STP works to provide this type of redundancy and how it works with link aggregation. In this video, I'm going to use 3 UniFi switches. One is the USW Pro 48 PoE switch, and in the middle, I have the Aggregation Pro. In the bottom, I have the Enterprise XG. The reason I chose these 3 were because they are the most important 3 switches in my home network. The PoE switch has many surveillance cameras connected. I want to keep them working even when I change other switch configurations. And for the Aggregation Pro, it behaves like a center of my home network. All the switches using DAC cables connect to it. From my other rooms, I have the fiber cables connect to it as well. If any device in my home network wants to connect to internet, it has to go through the bottom switch, the Enterprise XG. Let's take a look at the network diagram. From the PoE switch, I have 4 DAC cables connected to the aggregation switch, and I configured link aggregation among the 4 cables. And then from the Aggregation Pro, I have 2 DAC cables connected to the Enterprise XG. Similarly, I configured link aggregation here, and I use the Enterprise XG to connect to my router, which is pfSense. I configured link aggregation here as well. As a redundancy, I also configured this redundant link using a normal Ethernet cable. After plugging this redundant Ethernet cable, there's a loop. So if the system doesn't take any response, there will be disaster. Network won't be usable anymore. In the right side of the screen, I show the UniFi network controller. Let me find the USW Pro 48, very first switch in the left side. Then let me go to settings. See, this is the port status. The 4 blue links here are here. From the special icon, you can see they are for uplinks. That makes sense. They have been configured as link aggregation. From the tooltip, you can see the same. Then move on to the very first part. See the special stop sign icon? It says RSTP discarding. The RSTP is a protocol related to STP, the spanning tree protocol. The port status says blocked. That's exactly what we want because it's just a redundant link. Normally, when these 2 links work correctly, we don't want this link to be effective. But if these 2 links, for whatever reason, they have a problem, I want this link to take effective right away. That's exactly what STP can do. Another thing is, it doesn't matter what's the sequence I plug in this cable, these cables, and these cables. The end result will always be the same, which is these 2 will be showing effective and this one will be blocked. Let's see how STP guarantees that's the case. On the screen, you see 4 windows. This window is the diagram window. I want to keep it open so that we can look into the network diagram. The other 3 terminal sessions, I'm going to log on to the 3 different switches using SSH. I have already typed in the SSH command. Let me log on to them. Okay, We are in. As you can see, this one is for PoE, this one is for aggregation, this one is for enterprise XG. I'm going to use this PoE switch as an example and to explain the details about how to use CLI to check the STP status. Let me telnet to itself. We are in, and then use enable command, en for short. So we are in the privileged mode. Similarly, for the other sessions, I'm going to do the same thing. Before we go to the details, one comment about the CLI interface. If you have the non-pro version of UniFi switches, you may not be able to enter the telnet command and enter this CLI. But the reason I want to show the CLI in this video is just to show you how you can check the STP status. I'm not going to configure or change anything. Even if you don't have access to the CLI, it doesn't matter because the system do everything for you automatically already. So all the concepts, all the settings in controllers still apply. Another thing I want to mention is in the left corner, you can see this UniFi documentation about the STP and USW. It's a very good article, but it doesn't mention anything about link aggregation, which is the major thing I want to check in this video. It also doesn't mention the cost for SFP28. Let's try to figure out in this video as well. First, let's check the overall STP status for each switch. Let me start with the PoE switch. The command is here, show spanning tree MST detailed 0. By the way, you see the MST in many commands here. For some reason, even though the system only supports STP and RSTP, many commands has MST. I believe it's for historical reason. But anyway, this is the command. Okay, I will run the same command in other switch as well. And then we can analyze the result. In the end of the command output, the list or the associated VLANs, that's what the MST for, but it's not relevant to our today's video, so we can ignore them. From the UniFi network controller, you have no way to associate the STP with VLANs. This is the output for the PoE switch. There are several important information we need to mention. The second row, the bridge priority, that's a number we give in network controller. This one is the default value. If you don't change it, it will have this value automatically. This value is very important in STP. We will explain it later. Let's move on to the third row, which is the bridge identifier. You see a long string. It's very similar to the MAC address, a little bit longer. The first two parts, they are the priority. In hexadecimal format, this 800 is this number, and this number is the MAC address of this particular switch. Because this bridge ID is so important, I will note it in the diagram as well. And here you already see a interesting thing, the designated route. If you can see the other two sessions, you may notice it's the same because they are in my same physical network. They have the same root bridge. We will talk about the root bridge later as well. But now at least you can see all three of them have the same root bridge ID. The root path cost. We will discuss how we can calculate it so that we can understand how the system select the root bridge and how the cost is calculated for each switch. Now it's time to talk about the first problem, which is if you check all the three terminals about the designated route, as you can see, they are all the same, but they are not Enterprise XG. So you can see the Enterprise XG has this ID, ends with 2B85, but apparently the root is not the same one. In this terminal, you can see it clearly because this terminal is for the Enterprise XG. The root and itself is not the same bridge. So why is that? The way STP determines the root bridge is very simple. First, it checks the priority. The lowest one has the highest priority, but by default, the UniFi controller gives every single UniFi switch the same priority, the 8000. So that means the priority is all the same among all the UniFi switches. Then the only way to determine the root bridge becomes pretty random, which is to check the MAC address. The system simply chooses the lowest MAC address as the root bridge. Why this bridge is not the root bridge? Let's find it out from the UniFi controller. I sorted the MAC address in ascending order. So the first switch is supposed to be the root bridge. In the model number, as you can see, it's a flag SXG. It's not this Enterprise XG. That's why the system doesn't show this Enterprise XG as the root bridge. You can validate it here. See the MAC address here? It ends with 6346. Yes, that's the exact same one as the Flex XG. The system selects this switch as the root bridge purely based on MAC address. It doesn't make sense in my use case. I want this one to be the root bridge. Another thing, as you can see, this is my Enterprise XG. Before it, I have 1, 2, 3, 4 different UniFi switches. That means any one of these 4, if they gets rebooted or for whatever reason I added new UniFi switch which has even lower MAC address, this type of changes always impact the network topology. It will make my network unstable. That's what I want to avoid. Let's first examine the existing network diagram. Now I put the 2 additional switches in the link. Now we can see the complete picture and why the Enterprise XG is not considered as the root bridge. In the 3 terminal windows, you can see a very interesting value for each of them, which is called root path cost. In fact, the system used this value to determine which link should be active, which link should be blocked. I put the small table here. It's from Ubiquiti's STP cost calculation table. One of the topics for this video is to talk about the link aggregation and STP. This is where the link aggregation comes to the stage. Because if you have link aggregation in your switch-to-switch connections, the cost will be reduced. Why? Because the speed is faster. It's supposed to be the best option, right? So that's why if you have link aggregation, the system will automatically divide the original one link speed by the cable counts. Let's take this as example. I have 4 DAC cables. Each DAC cable has the 10 gigabit speed. So the total for link cost for this link aggregation is 2000 divided by 4, which is 500. And similarly for this one, 25 gigabits DAC cables. Unfortunately, I cannot find any official information from Ubiquiti about the 25 linkage cost, but just based on the value I observed, I assume the system used 800 as the 25 gigabits link. So for this linkage, the total cost is 800 divided by 2 because I have 2 cables. This linkage, the cost is only 400. Then let's look through the 3 costs one by one to understand how it's calculated. First, check this top switch, the PoE switch. The cost is 4,500. How is calculated? Very simple. The cost of this link plus this link plus this link. We already talked about this link is 2000 divided by 4, and this link is just 10 gigabits, so it's 2000, and this link is another 2000. So the total is 2000, 2500. So we ended up with 4500 cost. And for this bottom one, the X3 one, why is 4400? Because we talked about this link aggregation already. It's 800 divided by 2 and plus these two. So we end up with 4,400. That's how the system calculates the cost. Apparently, the current cost doesn't make sense to me because we don't have the correct preferred root bridge. Now let's talk about how we can correct it. To make this UniFi Enterprise XG switch the root bridge, it's very simple. We simply give it a very low priority ID. That's it. Let's go to the UniFi controller to do the configuration there. Let me find the UniFi XG here. In the setting, under services, let's find the STP here, and here we can set the priority. The default value is the number here. Let's choose the smaller number. As you can see, the priority increased by 4096. If we want to force this switch to be always the root bridge, we simply give it a 0. Then apply the change. And when this switch is done, I want the aggregation switch to be the root bridge. So there I want to give it a slightly higher number. So that can be the second option. Let me find the aggregation pro here. Go to setting, services, then give it a slightly bigger number. Apply the change. Let's complete the setting and go to the PoE switch to give it another priority, 48 here. Yeah, just for testing, I give it this number. Okay, once it's provisioned, let's rerun the same CLI command. Let's see what's the root bridge setting. So let me execute the same command again in each SSH session. For the PoE switch, let's see, now it has the new priority we just set, and now the cost is changed. We can discuss it later. As you can see now, for all the three switches, their designated route are all pointing to the Enterprise XG switch. Our setting changes are taking effect now. Next, let's dig deeper and check the port status for spanning tree protocol. In previous step, we ran this command, show spanning tree MSD detailed 0, to show the summary for the switch, but we haven't touched the port yet. Now let me run another command in this window. Remember, this window is connected to the PoE switch. Let me paste the command. The command is show spanning tree MSD port summary 0 or 0 is the MST configuration ID. In our case, we only have one spanning tree configuration, so it's always 0. Let me run the command. Depending on how many ports you have, there might be multiple pages. Let me keep hitting more. Okay, now I have all the results. Let me scroll up a little bit. See what's returned in these results. It shows all your interfaces or ports in your switch, and then it displays the STP mode and your SAP state and your port row. So these two columns are what we want to focus on in this step, because for STP mode, if you don't change your default configuration for every part, the STP is enabled. If you scroll down a little bit, for all the 48 PoE ports, they are listed here, and then it lists the 4 SFP plus, the 10 gigabit connections. For these SFP ports, the type is PCMBR. That means port channel member. The port row is disabled, which means if I configure the ports using link aggregation, the STP row for those ports are disabled. Then you may wonder how the STP works when we have the link aggregation parts. Continue to scroll down. You will see these strange items. They start with 3. The way UniFi name the interfaces is the slot and then port. Normally for physical slot, it only has 1, so it's always 0. But for 3, that's for logical interface, if you will. So they are not physical interface. For example, we configure the link aggregation, then we will generate a new interface. But it's not a physical interface, it's logical. So that's why here for 3.1 you see a port and the port row says root. That explains how the link aggregation works with STP. The logical interface will have the correct STP row for the port. Scroll up a little bit because I configured this red link on the first part. If you check the first port row, alternate. Basically, alternate means you have a loop, so the system block this part. You will see a stop sign if you check it in UniFi network controller. As long as the current root part, for whatever reason, is broken, then this one will be the new root. That's why it's called alternate. If we cut this link will become the real uplink for this switch. That's how the STP works. That's how the link redundancy works, because we have an alternate port row. We are not done with the first switch yet because we only displayed the part summary. I still want to go to the details of the first part and this link aggregated part to check more details. How we can do that? Let me paste the third command. The command is mst port details 0. 0 is the configuration ID. It's always 0 in our case. And then the slot, because we want to check the first physical slot, so it's always 0, and then followed by the port number. In our case, I plug in the Ethernet cable in the first part, so it's 1. Let's see what's the result. This is the port details when it comes to spanning tree protocol. Let's go through some major part. The first row is for port identifier. That's the internal identification for the port. The port row, it says alternate. I noted here as well. See, the port pass cost is 20,000. Why the value? If you check the table provided by Ubiquiti, you can see, okay, for 1 gigabit, that's 20,000. What this result tells us? Okay, it tells us this one is connected with a 1 gigabit cable. Now it's in alternate status and it's not really active, it's blocked. Now let's check the other part, which is the logical part, the link aggregation part. It will be more interesting. When we move on to this logical part, we want to run the similar command to display the part details, right? But one thing we need to know first, which is the channel ID for this logical interface. We don't know it yet, so that's why we cannot really run the command yet. Let's find out what's the channel ID for this link. I paste the command here. It's show part channel all. Okay, see here the logical interface 3.1 and the channel name is channel 1. It's link aggregation and you can see the member parts. And we know the interface is 3.1. Now we know the channel ID. We are ready to display the part details for the logical interface. This is the command we want to run. We say part detailed 0, which is the configuration ID, is always 0, followed by lag for link aggregation, then 1. We get the interface number here, which is 1. Okay, let's see the similar format as physical part, but let's look into the details. The port row is root. Maybe we want to spend some time to explain what's root port row. So root port row doesn't mean this switch is root. No, it just means this switch use this part to connect to root bridge. That's why this part is called, the row is called root. Then see the part pass cost is 500. Why 500? We already explained that. That's the 2000 per link divided by 4 because it's link aggregated. That's why you have the cheaper cost. Now let's talk about this part identifier. It says 8042. Let's go back to our very first command. Let's check the switch STP summary. This is the command mst detailed 0. See here, the very last line, root port identifier 8042. That's the exact port identifier we just see for this part. Okay, so everything's linked together. Then we are ready to move on to the second switch, which is this one. This one has multiple link aggregation parts. it will be more interesting. Because the second switch is a link aggregation switch, I have multiple link aggregation links configured. So we need to first find out what's the channel ID for this one and what's the channel ID for this one. Let's run the same command we just ran for the first switch. Let me paste the command, which is show port channel all. It will display the link aggregation status. Okay, it has 3 link aggregation interface returned because I know for these 4 blue links in the diagram, they are connected to from 25 to 28 physical port. So let's see which one. Yes, the second one. So let's note down this channel ID as channel 2. And for this one, I know they are connected to the port 31 and 32, the channel 3. Now we know the channel ID. Let's run the same command as we ran in previous switch to display the 2 logical interface port status. In the interest of time, I won't show you the details of the second and third switch command line results. You can use the same command to display whatever port you are interested in your environment. On the screen, you can see the current status for the USW Pro 48 PoE switch. The first part is showing blocked, that's this part, and the rightmost parts, they are link aggregation part and they are uplink. Now it's showing active. Let me manually unplug all the 4 SFP plus DAC cable, and then let's see whether the red one, the redundant link, can take the effective role. Now I have unplugged all the DAC cables for the 4 link aggregated parts. As you can see, they are turning gray now, one by one. Okay, they are all gray, and then if you look at the very first green part, now it's showing unblocked because now it's not determined whether it's uplink yet. Give it some time. Okay, now it's showing the correct status. It's showing the uplink. Yes, it takes time, but the system will recover just by itself automatically. That's the STP I would like to discuss in this video. Thank you for watching.